All right, good morning, students. How are you all? And I hope kindly come and join you all well. So today we are going to discuss 15th problem P of n 1 square plus 3 square plus 5 square plus and so on plus 2n minus 1 whole square is equal to n into 2n minus 1 into 2n plus 1 upon 3. So this we are going to discuss today. So how to discuss this out? You just need to listen now. Before going to start our class, let us close our eyes and we'll start our class. Sahil, good morning. And anyhow, Sahil, I want to explain to you something. So later I will, today itself I'm going to explain. Before going to that, just close our eyes. God kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life. Thank you, God. So, all right, Samuel, you asked me one question about n is equal to 2. How to prove? So, here n is equal to 2 means we have to take as two terms because it is summation was equal to that. So, what is that? A plus AR plus and AR square plus and small plus AR to the power of n is equal to AR to the power of n minus 1 upon r minus 1. This is right your formula. It is summation. So n is equal to 2 means you have to take two terms. Two terms means a and ar. So now what I am writing here it is LHS is equal to you are going to get as a plus ar. Then RHS also you need to get same answer. So RHS is equal to you already know that n is equal to 2 substitute r square minus 1 we can write 1 square upon r minus 1. Then a into r plus 1 r minus 1 upon r minus 1. R minus 1 get cancelled. Then ar plus a both will be the same. Then, therefore, LHS is equal to RHS. P of 2 is proved. Okay, that is about your doubt solved. And let's move on to the now our question. So, good morning to all who were present, and my appreciations to the Sahil once again because who was coming regularly and answering maximum questions and solving maximum. So remaining students also need to get my appreciations. That is what my wish. So kindly daily attend to the classes, learn something, and if you are having any doubt, you can ask me. One thing remember always in mathematics, if you are missed one class, is nothing but one chain. Your cycle chain was broken one means then it is not possible to move forward. So until you repair it, same method. If you lose one class, also it is more difficult to you all. All right, it is more difficult to you all. Kindly understand it and try to learn those all. Okay, right. So try to don't be absent to the class and come regularly and stay until the end. If anyone is missed in this live chat, if I won't find your name immediately, you will get a WhatsApp message again. Okay. So this is what we are going to. So that is automatically you are going to get. So please kindly stay until the end. All right. So, who are attending regularly for all my sincere appreciations to you all. Right. Here first, let n is equal to 1. So, here 2n minus 1 whole square. So, for 1 only term is enough. So, that what we need to take LHS is equal to 2n minus 1 whole square. 2 into 1 minus 1 whole square. 2 minus 1 is nothing but 1 square, that is nothing but 1. So RHS is equal to n into 2n minus 1, 2n plus 1 upon 3. That is equal to n is nothing but what I thought 1. So 1, 2n minus 1 means 2 into 1 minus 1, 2 into 1 plus 1 upon 3. So then what do you get after this? 2 minus 1, 1, 2 plus 1, 3. So 1 into 3 upon 3, 3 get cancelled, you get answer as 1. So at last we'll write, therefore, LHS is equal to RHS. Therefore, P of 1 is true for P of n. So first part is completed. Then let's move on to the second part. Let n is equal to P of k such that P of k is true for P of n. Here first itself we are assuming. Let means it is assuming. Let n is equal to k. P of k is true for P of n where k is any positive integer. Any positive integer. After that, what we need to do? Just wherever n is there, substitute k. So P of k such that 1 square, 3 square, plus and so on, plus 2k minus 1 whole square is equal to k into 2k minus 1, 2k plus 1 upon 3. Okay, this gives us equation number 2. Now to prove, let n is equal to k plus 1. To prove P of k plus 1 is true, what I need to do? So I need to take the complete step and one step need to be increased. Means one term need to be the increase. So P of k such P of k plus 1 such that 1 square plus 3 square plus and so on plus 2k minus 1 whole square plus one term exponent wherever k is there, k plus 1. So now we can write 2 into k plus 1 minus 1 whole square. So now here to here, you already know that has this. So substitute that value and get your answer. So that is equal to this part after equal to here I'm writing because there is no space here. So equal to after this, what is this? This is equation number 2. It says that this. So write that k into 2k minus 1, 2k plus 1 upon 3 plus here multiply 2k plus 2. So 2k plus 2 minus 1 whole square upon 1. 2 minus 1 is nothing but 1. So now we can write here k into 2k minus 1, 2k plus 1 plus here we are going to get as 2k plus 1 whole square. So this is upon 1 and it is upon 3. Take LCM as 3. When you take LCM as 3, k into 2k minus 1, 2k plus 1 plus 3 into 2k plus 1 whole square. And in both the places, 2k plus 1 is common. 2k plus 1 is common. So 2k plus 1 common, then you are going to get as k into 2k minus 1 into 2k plus 1 plus 3 into 2k plus 1 because here 2k plus 1 2 times is there. 1 is your common means 1 should be again. So right here 2k plus 1 that is upon 3. Now, anyhow 2k plus 1 common, right? This part not there. So when you common, it is not there. So next one, just you can simplify this. 2k plus 1, k into 2k, 2k square minus k into 1, k plus 3 2s are 6k plus 3 1s are 3 upon 3. Just simplification only. I am not doing anything extra in this. Only simplification I was doing. So anyhow, I'll rub this part. So I hope so you won't get any doubts in this. Just normal procedure which we were done in previous all classes. So only just simplification only you have to understand. And now anyhow here what is left that part, right? That is equal to 2k plus 1, 2k square, 6k minus k plus 5k plus 3 upon 3. Now 2k plus 1, 2k square plus 5, 3 2s are 6. So now 2k square plus 2k plus 3k plus 3 upon 3. So 5k I was split into 2k and 3k. So now 2k plus 1 in both 2k common k plus 1. In both 3 common k plus 1 upon 3. In both now k plus 1 is common, 2k plus 1 k plus 1. What is left? 2k plus 3 upon 3. This is nothing but k plus n plus k plus 1 came, and 2n minus 1 means going to get as 2k plus 1, and then 2n plus 1 is nothing but you are going to get as 2k plus 3. So wherever n is there, you got as k plus 1. If you want, let us check here. So k plus 1 as it is, I'll write. Second one, it is 2 into k plus 1 minus 1. Next one, 2 into k plus 1 plus 1. Check now. Wherever n is there, you got k plus 1 or not. So first here n is there, k plus 1. So this term completed. Next one, it is 2k plus 1 minus 1. I was written. Just simplify here. 2k, 2 minus 1 is nothing but 1. 2k plus 1 already is there. And next one, 2k plus 3. So all are completed. Therefore, we can say that P of k plus 1 is true for P of n. This is your equation number 3. At last we write therefore from 1, 2 and 3, from 1, 2 and 3, we can write as P of n is true for all natural numbers. Okay, so that is about it, not more than that. Now let's move to the problem number series. Once again, after completion of the class, revise it by watching again this. Otherwise, it is very difficult to you to understand. So why I am going this much fastly? Because I was explaining to you minimum I think 3 to 5 classes, one by step I was explaining, and now it is not required that much step by step. Only simplification required for you. Okay. So anyhow, Sahil only written the splitting terms. Kushi you also do. Anil from Kushi, Garima, Dhruv Vaishnav, and remaining all students also need to do the work. And Dai Agarwal also, he was also a good student who was replying for me maximum times. But now he was just silently is there. I don't know what happened. So some classes, if you are absent like this, only the problem. Hmm? So don't be absent, and everything will be good for you all. Okay, now 16th one, 1 upon 1 into 4, P of n is plus 1 upon 4 into 7 plus 7 upon, sorry, 1 upon 7 into 10 plus and so on plus 1 upon 3n minus 2, 3n plus 1, that is equal to n upon 3n plus 1. Very simple question. This is the same procedure. I will solve fast firstly, kindly concentrate. Okay. So now first let n is equal to 1. So now first LHS is equal to 1 upon 3n minus 2, 3n plus 1. Just substitute now wherever n is there 1. So 1 upon 3 into 1 minus 2, 3 into 1 plus 1. So you are going to get 1 upon 3 minus 2 is 1, and 3 plus 1 is nothing but 4. So 1 upon 4. RHS, let me write here n upon 3n plus 1, substitute 1, 3 into 1 plus 1, that is 1 upon 4. So at last, therefore, LHS is equal to RHS, therefore P of 1 is true for P of n. So next question answer, last questions we have to tell. Okay, right. So that is about it, and then let n is equal to k, and then we can write as P of k is true. This step is common for all problems. P of k is true for P of n, where k is any positive integer. Any positive integer. Okay. So then P of k is such that 1 upon 1 into 4 plus 1 upon 4 into 7 plus and so on plus 1 upon 3k minus 2, 3k plus 1, that is equal to k upon k3k plus 1. So simply what I was done, wherever n is there in this, substitute k. That is equation number 2. Next, let n is equal to k plus 1 to prove P of k plus 1 is true. What I need to do? So just you can write this step again. So that is P of k plus 1 such that 1 upon 1 into 4 plus 1 upon 4 into 7 plus and so on plus 1 upon 3k minus 2, 3k plus 1. So one step extra I need to write. So plus 1 upon, wherever k is there, substitute k plus 1. So 3 into k plus 1 minus 2. So when you are writing brackets, you should be careful. Only k place I was substituted k plus 1, not some other place. Same method here also 3k plus k plus 1 plus 1. So let me simplify it now. Here to here from equation number 2, what is there that you can write? That is k upon 3k plus 1 plus and write remaining part 1 upon 3k plus 3 1, so that we can write 3k plus 1. And now 3k plus 3 plus 1 4. So 3k plus 4. So here write from to 3k plus 4. So here 3k plus 1 is there, which is not there. 3k plus 1 is there, which is not there. Here 3k plus 1 is there, which is not there. 3k plus 4. So write k into 3k plus 4 plus 1 into, here both are there, so write 1 into 1. So now we can write 3k into k, 3k square plus k into 1, k plus 1 upon, now 3k plus 1, 3k plus 4. So 1 3s are 3. So I need to write, I need here 1 here. And any other is possibility is there. Sorry. Here it is 3k plus 4, not 3k plus 1. 3k plus 4, 3k square, 4 into k, 4k. So 1 3s are 3. So then we can write 3k square plus 3k plus k plus 1 upon 3k plus 1, 3k plus 4. And let me simplify this. So I'll rub this part. I think this part is enough. I think. Let me see. Equal to in both 3k common k plus 1 and plus here 1 common k plus 1 upon 3k plus 1, 3k plus 4. These are just factorization. If you know properly, this becomes a dead easy. If you don't know factorization, it becomes very difficult. So now in both again k plus 1 common, k plus 1 we can write, then remaining 3k plus 1 upon, so 3k plus 1, 3k plus 4. So now you can check carefully, this 3k plus 1, 3k plus 1 get cancelled, you get k plus 1 upon 3k plus 4. And this we can write it as k plus 1 upon 3 into k plus 1 plus 1. Check now 3k, 3 1s are 3, 3 plus 1 4. Possible. So now wherever n is there, Check here, k plus 1, k marna. Yes, you got as wherever n is there, 3 k plus 1 you got, so that it is true. So therefore, P of k plus 1 is true for P of n. Equation number 3, therefore from 1, 2 and 3, P of n is true for all natural numbers. All natural numbers. So that is about your problem number 16. Okay. So very simple, but you just need to concentrate on those. All right. So now let's move on to the problem number 17. So now I'm going little fast. N is equal to 1, then LHS is equal to 1 upon 2n plus 1 into 2n plus 3. Wherever n is there, substitute 1 upon 2 into 1 plus 1, 2 into 1 plus 3. Now 1 upon 2 plus 1, 3. 2 plus 3 is nothing but 2 plus 3, 5. So 1 upon 15, go for R, n upon 3 into 2n plus 3. Substitute 1 upon 3 into 2 into 1 plus 3. 3 plus 2 plus 3, 5, 5 3 is 15, 1 upon 15. So at last, therefore, LHS is equal to RHS. Therefore, P of 1 is true for P of n, equation number 2. And then, sorry, equation number 1. Next, what we need to write in this, let n is equal to k. P of k is true for P of n, where k is any positive integer. Okay, after writing that, P of k is such that 1 upon 3 into 5 plus 1 upon 5 into 7 plus and so on plus 1 upon 2k plus 1 into 2k plus 3, that is equal to 1 upon, sorry, k upon n means that is k. So 3 into 2k plus 3. So you got this. This is equation number 2. Next one, let n is equal to k plus 1 to prove P of k plus 1 is true. So you are trying to solve by your own, only whenever you get the doubt, that time only you have to observe on the board. So you have to try by your own. Whenever you are getting doubt, that time only you have to observe on the board. Okay. So now let us check now this part. So P of k plus 1 such that as 1 upon 3 into 5 plus 1 upon 5 into 7 plus and so on plus 1 upon 2k plus 1 into 2k plus 3. One step need to be increased. So 2 into k plus 1 plus 1. Another one 2 into k plus 1 plus 3. So now this is what we need to know. And this part you already know from equation number 2. What is that answer? K upon 3 into 2k plus 3. Plus this simplify 1 upon 2k plus 1, that is 2k plus 2 plus 1, so 2k plus 3, 2k plus 5 from equation 2. Just simplify, you get like this after getting. So in the LCM place, LCM I won't take. What I'll do is common here. Nothing is there, means 1 upon 2k plus 3 common. 1 upon 2k plus 3 common. When you common this, k upon 3 plus 1 upon 2k plus 5. Just simplify it by cross multiplication. 2k plus 3, k into 2k plus 5 plus 3 into 1, 3 3 into 2k plus 5. So just simplify it. So I'm going to simplify here itself. I'll try 1 upon 2k plus 3. And here 2k into k, 2k square plus 5k plus 3 upon this as it is right. 2 into 3k plus 5 only right as it is right. So now let me rub this part and I'll solve here that part remaining. So that is equal to 1 upon 2k plus 3. And then I'm going to write little fastly. I was writing, just concentrate it. So now 3 2s are 6. So now what I'll do here is this, split this as 2k, 5k split as 2k plus 3k. 2k square plus 2k plus 3k plus 3 upon 3 into 2k plus 5. So 1 upon 2k plus 3 you can write here. And this part in both places 2k common. 2k common means k plus 1 you are going to get. Plus in this both 3 common k plus 1 you are going to get. Upon 3 into 2k plus 5 bracket close. So after that 1 upon 2k plus 3. And in these both k plus 1 common k plus 1, what is left? 2k plus 3 upon 3 into 2k plus 5. Okay. Now check 2k plus 3, 2k plus 3 get cancelled. K plus 1 into 1, k plus 1, 3 into 2k plus 5. Now this still we can simplify. K plus 1 upon 3 into 2 into k plus 1 plus 3. You check now whether you get this 2k plus 5 or not. 2 into k, 2k. 2 ones are 2, 2 plus 3, 5. So that this is same. Now check wherever n is there, k plus 1 is there or not. See here n, k plus 1. And here 2 after n is there, n plus k plus 1. So that it is true. So at last we can write therefore p of k plus 1 is true for p of n. For p of n. At last, therefore, this gives us equation 3. Therefore, from 1, 2, and 3, p of n is true for all natural numbers. Okay, so that is about your problem number 17. So let's move on to the problem number 18 now. All right, we have to complete fastly. So I hope 17th one you all understood. Let's move on to the 18th now. All right. Totally 24 problems are there here. So now in this your 18th one, 1 plus 2 plus 3 plus and so on plus n is less than 1 upon 8, 2n plus 1 whole square. Check now carefully. Let n is equal to 1. This is your p of n. Here less than symbol is there, you need to get answer also in the less than manner. So now you can write here LHS is equal to only n is nothing but 1. So then go for RHS. RHS is equal to 1 upon 8, 2n plus 1 whole square. 1 upon 8, 2 into 1 plus 1 whole square. So 1 upon 8, 2 plus 1, 3 whole square. 3 square is nothing but 9, 9 upon 8. So now here it is 9 upon 8 is greater than your LHS. In other words, we can say that LHS is less than RHS. You may ask how, sir? 1 is less than, this is we can write as 1 upon 8. So in the mixed fraction, when you are converted this, improper fraction into the mixed, you are going to write 1 upon 8. So therefore LHS is equal to LHS is less than RHS happened. So I'll write therefore P of 1 is true for P of n. This gives us equation number 1. Same only, whether less than, greater than, all will be the same method only, no changes. Let n is equal to k, p of k is true for, this step is for all same. For p of n, where k is any positive integer. So P of k is such that 1 plus 2 plus 3 plus and so on plus k is less than 1 upon 8 2k plus 1 whole square. Okay. So now next, this gives us equation number 2. Next step what we need to do? Let n is equal to k plus 1 to prove P of k plus 1 is true. What I can do? So when k is there, k plus 1, right? And one step extra you have to write. So 1 plus 2 plus 3 plus and so on plus k after next step will be k plus 1. Okay? So one step extra, or we can say that one term extra you have to write. So now up to k, you already know that this. So you can substitute that as, now you have to write here less than symbol because we are finding the less than one. So it should be less than symbol. So anyhow that we will check the last moment whether it is less than to that or not. Anyhow here I am going to write this full part is 1 upon 8 to k plus 1 whole square plus k plus 1. Okay. So here this full we can write it as less than 1 upon 8 2k plus 1 whole square plus k plus 1. Then just we can simplify it. So whatever the possibilities are there, let me check. So less than 1 upon 8 2k plus 1 whole square plus k plus 1 upon 1. Then LCM we can take. LCM is 8. 2k plus 1 whole square plus 8 into k plus 1. Then just simplify again. 2k means that is 4k square, just a plus b whole square formula. A square means 4k square plus b square is 1 plus 2 to the 4k plus 8k plus 8 upon 8. Just simplifying, I'm not doing any magic in this place, just simplifying that. Okay. So now less than 4k square plus 8 plus 4 is nothing but 12k plus 8 plus 1 9 upon 8. So now 9 fours are 36. So for 36 we need to check 6 6 are 36. 6 plus 6 is 12, it is possible. Then in which table 36 possible? 3 table also possible. 3 12s are. So 12 minus 3 not at all possible. Next 12 threes are also possible. And 4 table 4 nines are possible. But here we could not be able to get 12. So you found here where you are possible to get 12 means only 6 and 6. So you can take here 12k means 6k plus 6k. So less than 4k squared plus 6k plus 6k plus 9 upon 8. So that is less than. So in both places 2k common. Then you can get as 2k. So 2 2s are 4, k into k square plus 2 3s are 6. So that k 6k you are going to get plus in this place also 2 common, sorry 3 table, 3 common, 3 2s are 3 3s are upon 8. And this part again I am going to rub. Anyhow we are going to get our answer. Whether it is less than or greater than, same procedure you have to follow. Less than is that less than keep, greater than is that greater than keep, less than next. So here it is 2k plus 3 is common. So now we can write 2k plus 3, and again you are going to get 2k plus 3 upon 8. So less than 2k plus 3 whole square upon 8. This 1 upon 8, we can write 2k plus 3 whole square. And this still less than 1 upon 8, we can write this as 2 into k plus 1 whole square. Check now carefully. N plus k plus 1 came. Check everyone. N plus k plus 1 came. This is our what? Our magic. So you have understood our magic is what? Simple magic now. See here it is. We solved all as usual by using our procedure. At last we got as C n plus k plus 1 I was written. So when you multiply, you check this, you are able to get our 2 into k, 2k, 2 ones are 2, 2 plus 1, 3 wholes upon 8. So at last we'll write here it is. So hence it is proved wherever n is there, I need to get k plus 1. K plus 1 I got. See, here what is the difference between previous one and this is only less than symbol. So I was kept everywhere less than symbol. Simplification only you have to concentrate. So here all simplification after I was checking 2k plus 3 whole square I got. But I need wherever n is there k plus 1 I want. So simply what you need to do is 1 upon 8, 2 into wherever n is there, substitute as k plus 1 whole square. Then check whether your answer is right or wrong. So what I was done here, 2 into k, 2k, 2 into 1, 2, 2 plus 1, 3. So that 2k plus 3 whole square. Simply anyhow, again I write here 2k plus 1 plus 1. 2 into k, 2k. 2 plus 1, 2 into 1, 2 plus 1. So this is 2k plus 3. Will write or not? This is what I was saying. Okay. So that is what your problem. So less than 1 upon 8, 2 of k plus 1 whole square. So now we can write here. I hope now Sahil is understood this. So now at last we'll write therefore P of k plus 1 is true for P of n. Anyhow, I won't little fastly. You just again go through your offline video, then once again revise, you can understand little more clearly. Okay. So now at last we write here, therefore, this equation preview from 1, 2, and 3, P of n is true for all natural numbers. Okay, so that is about your problem number 18. Okay, all right. I think Sahil also understood. Okay, so that is about your problem number 18. Very good. All students are now present today. But now I think some students went again. Who are those? All right, we are discussing again and again, right? Okay. So up to here we discussed. Now remaining problems is a remaining problems discussing is very something little bit different. I said second model. So now 19th one second model. P of n they given as n into n plus 1 into n plus 5 is a multiple of 3. Is a multiple of 3. So such kind of thing the given means what we need to write. So this is multiple of 3 they given. So how can I solve? Is there any way to solve this? So you need to talk to me now. How can we solve and what is the possibility to solve? Okay. I think you don't have any idea because it is this kind of question first time you got right. So what we need to do is whichever is there first, you can write this as n into n plus 1 into n 5 is equal to multiple of 3. 3 into any number, any number you can write. So I may write as any letter. So letter will be like I may take as now P. So it is a multiple of 3. So 3 table, that is 3 ones are 3 happen, 3 6, 3 3s are 9. So means multiple of 3 means what are those possible? 3, 6, 9 and whichever it is, all we can call it as multiple. But 3 is common for all. 3 ones are, 3 twos are, 3 threes are, next 3 fours are. You will find in all the places 3 is common. That's what we'll say that as a 3 multiple. Okay, so first we think this in this way, and first let n is equal to 1, LHS is equal to n into n plus 1 into n plus 5. So just 1 into 1 plus 1 and 1 plus 5. So you are going to get as 1 into 2 into 6. 6 twos are 12. This we can write 3 into 4. So it is a multiple of 3 or not? Yes, it is multiple of 3. LHS is equal to 3. RHS is equal to 3. Here we cannot substitute anything, but here we need to check whether these both are multiple of 3 or not. Previously, you are checking that LHS must be equal to RHS, but in this case, P of 1 is 2 means it is just a multiple required. Okay, multiple of 3 required. So we can write here it is. So LHS place would be just substitute 1 and check whether it is multiple of 3 or not. So directly we can write here, therefore it is a multiple of 3. Therefore, P of 1 is true for P of n. Equation number 1. This is second model. Everyone concentrate it. So next, let n is equal for this same procedure again. Let n is equal to k. Then we can write it as P of k is true for P of n, where k is any positive integer. All right, k is any positive integer. After that, what you need to do? So just P of k such that k into k plus 1 into k plus 5 is equal to 3. P only. We can't change anything in this. So next step, how can I solve? This is what a terrible one now for you all. So up to here it is okay. So no problem you will get. After this only you need to get you will get some problem. So this I'll give as equation number 2. After this, what we need to do? How to do? So these are, I don't want to explain now. You just go through your textbook and first try to understand it, and let's come tomorrow, so that tomorrow we are going to discuss the remaining part of this problem. Okay, but tomorrow is completely different session for you all. If my voice is good, that time only I'm going to take you. Completely different session, because these kind of multiples problems only we are going to solve tomorrow total. Example problems also we'll discuss, and this exercise problems also we'll discuss. Total 25 problems are there in your textbook. So I think still I think that 6 problems are left. So that 6 problems, if we are completed, this chapter is going to be completed. I hope so. Within this week, we are going to complete this full chapter. And anyhow, your miscellaneous exercise I'm going to give as a homework, and that you have to complete, and the papers you have to submit to me. Okay, so that I can know that whether you are understood concept or not. Next one, it is after completion of this, our third chapter only we are going to start. And before going to start that third chapter, I'm going to send first formulas list. You just prepare first all the formulas. So then we'll go for our problems. Then it's going to be very easy for you. Okay, that's all for today. And one more thing, that is kindly you need to stay until the end for the class always. And if your friends are willing to learn, so whether they are from some other places also, let them come and join here. Okay, right? May God bless you all. May God bless you all.